So, hello everyone. First of all, I hope that you can all hear me loud and clear and that you can see me. If you have any issues, well, I'll start like in 1 or 2 minutes with the presentation itself. So to give you some time to adjust your computer and to adjust the volume and the screen. So just make sure that you can see the presentation slides in the background and also the camera, and then we are ready to start very soon. First of all, let me say that we are more than thankful and overwhelmed that we have more than 300 registrations for today's webinar, which is very, very good and a very good result for us right now in this, let's say, interesting and of course very challenging times. So first of all, before we start, I hope that you are all healthy and safe, and that goes of course also to all of your family and friends, and we all at BEGO keep our fingers crossed that it will stay like that for all of us and all of you, and that we all can come back to what's like a new normality or a new normal in the very near future, and can all pick up our old businesses and all our lives as usual. So we took the opportunity to start this series of webinars to, well, do something in this times to go on with the education online and worldwide, because we can't go to each of your countries right now. But what we can do is we can be here, we can stay home, but yes, actually, we can support you also from here. What we're doing today, the topic of today's webinar is BEGO Guide, and how easy it is nowadays to use digital techniques in daily practice. And what I'd like to show you in the next about 40-45 minutes is what you can do to adapt digital techniques in order to use it on a daily basis. And I want to show you what kind of techniques do make sense, and what the digital technology can do for you, because my opinion is that not everything that is digital is useful because it's digital. Every digital technology for me has to serve a certain purpose. And the purpose itself, it's not that it is digital, but it needs to have certain advantages over the existing analog technologies. That said, let's start with some numbers which I find very interesting. If we take a look at the age of digital techniques, it's interesting that high-speed internet, DSL, which is called in Germany, like high-speed internet, is now on the market since 20 years. The iPhone is 13 years old in 2020. 3G mobile telecommunication is now on the market for 15 years. Netflix itself is on the market for the last 23 years. Of course, they didn't start with online streaming. They started with shipping DVDs and Blu-rays 23 years ago, but also 13 years ago they started online streaming, and the DVD itself is now on the market for 27 years. Looking at that numbers, it is very, very astonishing for me. I mean, I am kind of one of the generation of the digital natives. When my parents bought their first computer, I was about 8 years old. So I kind of grew up with computers, but I also well, witnessed all the development and advancements in digital technologies. But now looking back, it's very, very interesting to see which of the technologies that we use nowadays on daily basis, like how old they actually are. And for me, it's interesting to see what's new for us now. What was added to that in the last 3, 4, 5 years, or even only in the last year. But also for me, what I already said is digital technologies is not a purpose on its own, because not everything is digitally possible. If we look at this number, 14 million packages have been shipped by the Amazon Prime program in 2017. And if you think that is a high number, let me tell you that this is the number of shipments per day. Current numbers say that actually in this last 2 months of lockdown, of crisis, those numbers went even up significantly, showing that not everything is possible in the digital world, because we need those bridge technologies to combine the analog and the digital world. Because if we need, for example, a screwdriver at home, we still need to go to a shop or order it online, and it needs to be shipped so that we can hold it in our hands, because it's not possible for us to just download a screwdriver. Very simple example. So we need technologies that help us from the digital world into our analog world, and those interfaces I also want to show you today. So what else came to the market in the last years, which is like interesting new technology? That said, not everything that is digital makes sense. What also sounds and seems a bit anachronistic is the first example, the suitcase, where you don't need to have this paper banderole, this paper sticker if you fly somewhere, but you have an e-paper display built in your suitcase, where you can download that sticker to the suitcase. Is it necessary? I doubt that very much, because for me the concept of the sticker always worked. Second example, a coffee mug which has Bluetooth, and you can choose on your phone the temperature that the coffee should maintain. Also, a thermal mug was for me always very, very convenient. And the third new system, what I found lately, is a dispenser for shirts, where you can choose on your app, I need a white shirt, and it will give you a white shirt. And also here, well, for me, the concept of a classical wardrobe, where I just open up the doors and see what's what, also worked pretty much for me in the last almost 40 years. So not everything which is digital does make sense because it is digital. But on the other hand, there are many technologies nowadays that can help us, and especially in the digital dentistry world. That said, let's take a look at this, because what I always say, if we start with an implant surgery planning, of course, we need to take a look at what's what. We need an actual planning. Of course, this is a picture that I got from the internet. Of course, it's not an example of like daily practice. It's actually, I tried to count all the implants, like 42 implants in one jaw. It is extreme, yes, but also here someone had an idea, and the idea was to place as many implants as possible. So there was kind of a planning, but of course, this was an analog planning, and what we do is we wanted to have it digitally. But for me, what's even more important when I speak about digital technologies, and especially about digital case planning, is that we need sometimes a change of perspective. Because sometimes what we think that we see is not what's actually there. I don't know if you have seen this discussion was last year, where Prince William was accused of like showing the middle finger to the press. There was kind of a scandal in the social media going on. But also, if you take a look at the next image, which was just another perspective, that shows what went on in fact. So the difference was huge. The meaning of that gesture was totally different. It was just showing the number 3, but the media, the social media, like scandalism, social media made this out of that. But if you look how it is in reality, that made a huge difference. So it is always important to see things not only from one perspective, but also like from a different perspective. And that's what we also try to do in digital dentistry. And planning sometimes would have been so great. Those are also examples that you can easily find when you are talking about digital case planning. And there is a Facebook group called Dental Bloopers. It's a big recommendation for you to check. It's very interesting to see what can actually go wrong in dentistry. And those are really good examples of things where I actually have no clue why that happened, but obviously they happen. But what can we do against it to prevent such things? I'm now focusing on digital dentistry for the last 13 or 14 years. I started working in the dental industry in 2006. I started working for Materialized Dental, a company known for the Implant software. Nowadays, it has been bought by Dentsply, and it's now part of Dentsply Sirona. But like for the first 5 years of my business life, work life, I was selling 3D planning software. Then in 2011, I changed to BEGO, and since then, I'm also focused on digital dentistry. So approximately in the last 14 years, I planned far more than 10,000 implants digitally on the screen. So I have seen a lot of different X-rays, and many times there were implants already in place. And so I could have a good overview of what was already placed. And some of those examples, what I found in X-rays over the last years, I'd like to show you here, because in all of those cases, the normal classical two-dimensional OPG, like the classical two-dimensional X-ray, didn't show anything too significant in these pictures. And only in the 3D imaging, it actually showed that those implants, to say the least, are not exactly placed in an optimal way. So until it was planned to do more implants in those cases, it was not known that the existing implants weren't placed what you would call precise. So what's the alternative? The alternative is to plan it in 3 dimensions. And again, not only because it's 3D, it has to be necessarily better. But what I'd like to show you is what it is, or what is possible, and what you can do with that. Because nowadays with digital technologies, it's possible to combine different layers of information. So what you see in this image is not only a 3D X-ray, in this case, cone beam scan, but is also a visualization of the implants that are about to be placed. It's also a visualization of the master sleeves, which will be later put in the surgical guide. And it also shows the outline of the prosthetic restoration. And in previous years, this was called backward planning. So what did you do for backward planning? For backward planning, you had to do the cone beam scan with a special scanning appliance, a scanning prosthesis. So even before you did the cone beam scan, you had to prepare a scanning prosthesis out of a radiopark material. Very often also use reference markers, and then you could do the X-ray. But what you didn't know in advance is if there is enough bone for an implant surgery, or if you would need, for example, sinus graft. So in all those cases, you would sometimes do a scanning prosthesis with a huge effort without actually having needed it in the first place. But digital technologies actually enable us to go different ways and to do things in different orders and do things in the moment that we need it, and not needing to plan that far ahead and that far in advance than previously. So what I'd like to show you is what needs to be done if you want to have a surgical guide nowadays, and what you can do with the digital technologies. Let's have a look at this situation. It's like very classic. We have jaw that lacks some teeth, and as a result, we want to have implants. And there starts actually the first question. Which of your patients comes to the dental office and says, hey, I need implants? Most patients come to the office and say, I need teeth, I need function, I need aesthetics. So I want to be able to eat, I want to be able to speak, and I want it to look good. For the patient, it doesn't matter if it's done with an implant or any other way in the first place. So the important thing is the patient needs teeth. But what do? We do generate data. And how do we generate data nowadays? Of course, we need a cone beam scan. And there it's very interesting. When I started in 2006, sorry. In 2006, when I started, cone beam scans weren't actually on the market. There was the first Newton device, which was limited because it had only 300 different gray values. It was very bad. So 99.9% of the images taken for surgical guides, which did exist by then, were done by CT scans. Nowadays, 99.9% of all images that we get in our planning center here are cone beam scans. So a lot changed in the last years. It gets more and more easy. It's much more easier, in fact, to get those images, and also, of course, the price for those images went down, which made it also more affordable and more easy to adapt this kind of technology for daily practice. So what you get is a CBCT scan, which is nothing else than a 3D X-ray. So you have different slices, up to 500 usually slices of the patient's jaw, which you can then re-slice in every angle and in every axis that you want to have a look at. So you know exactly where is enough bone, how much bone is there, and which implant you could theoretically place there. Because one more advantage, of course, is you don't have much of a distortion in a cone beam scan. In an OPG, in a two-dimensional X-ray, you can have up to 25% distortion, which makes out of a 10 millimeter implant that you plan, like a 12.5 millimeter implant, which is a huge difference. So no distortions or deviations are much less in a cone beam scan. But speaking of daily practice, this is like the first I don't want to say advice, but tip for cone beam scans. Make sure that the patient has a stable bite while during the cone beam scan, because we get a lot of images where the image is shaken. And very often we see that there is a gap in the mandible, like that the image is shifted in the mandible because the patient lost the prosthetic position during the cone beam scan. And then for a case planning, it's not possible to continue with that, because with this deviation, it's impossible to create a surgical guide, and you would need to take a second X-ray. And also, like, the overall quality of the cone beam images is significantly reduced when you also have just a little bit of movement in the image. So what we always suggest is to make a very, very easy splint for the patient, so that he has a fixed bite and there's nothing to shift in that position, so that you get the best overall result. But much more important, because what is much more neglected during case planning is the gypsum model, the plaster model. Because what we see is that a cone beam scan is always done to a certain protocol. And you know you have to position the patient in a certain way. You know you need to export the files in a certain format. That is all clear, and it's seen to be precise because it is digital. The thing is, the second thing we need for the case planning is a plaster model, because in a cone beam scan we don't see the soft tissue, and we always have scatter and artifacts and a much lower resolution compared to a plaster model. So when we are taking a cone beam scan, we're talking about a voxel size, so a three-dimensional pixel size of 300 micron. But when we are taking a plaster model, we are talking usually about precision in 30 micron area, so which means it's like 10 times more precise on the plaster model than in a cone beam scan. But only if you do it right. So we see a lot of cases where there's no focus on the precision of the plaster model. This is one example. This is actually a case that we got for our planning center, where a customer sent us this plaster model and wanted us to prepare a surgical guide. And I have to say, the result, the surgical result, can always be only as precise as the data you put in. So this principle, input equals output. A customer said to me once, shit in, shit out. So if you put bad data in from the start, you can't expect to have a precise result in the end. And I have a second example here about that. That's a scan of a plaster model that we got also for creating a surgical guide. And I asked the customer in this case, hey, what do you expect us? The surgical guide that we can build on this model cannot fit on the patient's jaw, because everywhere where we have a bubble and thus a hole in the scan or in the plaster model, there will also be, this will also be reflected in the surgical guide. So if you try this guide within the surgery, it cannot fit, because everywhere where there's a hole in the plaster model, there is a positive amount of material in the surgical guide. And because those holes don't exist in the patient's mouth, it cannot fit and it will not fit. So customer the daily life advice or a daily life tip: focus on the plaster model. That said, if we compare the different materials that you can use for an impression, we have seen major deviations when using alginate impressions compared to polyether or silicone impressions. Some months back, I was in a surgery by myself, of course, just well, watching it and giving advice. But the patient was sitting on the chair and the surgical guide was tried in and did not fit at all. So we tried to make it fit for the surgery, but we failed. It was not possible to modify the surgical guide in a way that it would fit. And I asked the surgeon, how did you do the impression? He said, yeah, we did the alginate impression on Friday afternoon, gave it to the lab, and then they send us the model, and we send that model to you for scanning. So what happened there was that the alginate, of course, was deformed, dried out, and we had deviations of up to 0.6 millimeters. And how did we measure this? What we did is we did a second impression with a polyether and superimposed those two data sets. And this is what you see here on the image. In this superimposition, we were very easy able to see the huge differences between those stone models. And that said, our recommendation is always to use a polyether or a silicone impression if you want to do a surgical guide. Of course, alginate, if done correctly and all done to protocol, is precise. We know that it's gold standard for impression, but it can be faulty. It can be done in a way that you get deviations, and that's why we recommend different materials like polyether or a silicone. And also, usually I wouldn't think why it needs to be said, but we also get a lot of stone models packed like this, where we say, okay, we don't need to have like a bulletproof packaging, but it should be safe and should be fit for being shipped, actually. DHL says you need to pack an item in a parcel that it withstands the forces of a drop of 1.50 meters approximately. So if you pack a plaster model the next time and you put it in a parcel, just try to drop it from the table. That's like 1 meter approximately, and that should be your height that the gypsum model needs to withstand, and then you are quite safe that you don't send out a plaster model that will be broken and thus not usable on the other end. If we see that it's broken, that's the easy part. The problem is if like some small edges or like incisal edges break off, which you can't see or don't know that it is that way, if it's not obvious, then we would produce a guide which will just not fit during the surgery. So previously, analog technologies, they were quite complicated. Now we do like the move towards surgical guides. Previously, you needed, like I said, a scanning prosthesis, often reference markers. Then those drilling tables were used to produce those guides. But nowadays, we have the opportunity to just 3D print them, which makes it very, very easy and affordable for us to work with that. So just a quick overview, how does it work? What can we do in current scanning softwares and 3D case planning softwares? What we all know, it's the same in every 3D software. You need to define the panoramic curve. You have to superimpose the plaster model with the cone beam scan. Then you draw the nerve channel for some security functions. You can add a virtual setup, which I'll explain a bit later. And then the idea is, of course, that you plan the implants coming from a library so that you can plan directly that implant that you will place during the surgery. You can adjust the length, the width, the angulation, the depth of the implant in order to have the best possible outcome and to measure exactly which implant in which position fits best. Then in this example, you draw the outline of the surgical guide. You adjust the position of the sleeves where you want to have them. And as a result, you can add some viewing windows like that. You can see that the guide is really placed correctly in the patient's mouth. And the result is that you get a surgical guide. I mean, this overall concept that is clear, that is known for the last years, and that is the important part, that's not everything. For me, guided surgery is a lot about prosthetic planning. But when we get plannings, for example, in our planning center, we often see that we only get a cone beam scan, information where implants should be placed, and that's it. We don't have any prosthetic information. We don't have any information, well, how the prosthetics are planned. The only thing we know is whether or not it should be a screw retained or a cemented solution, or it's a locator or a bolt attachment. That's what we know. But if we take a look at this image, I have to question if it's really an advantage to plan here and do a surgical guide, because honestly, you don't actually know where the implants should be placed. You can place them in the bone, of course, yes. But as I said in the beginning, it's important to see that the patient doesn't want to have implants, he wants to have teeth. So a term that I introduced here is what I call retrospective backward planning. That means that you do the backward planning after the cone beam scan. So you add the prosthetic information at the time and at the moment where you need it, and not in advance thinking you might actually need it, but later on in the process when you see in the cone beam scan, yes, there is enough bone for implants, but I need an additional layer of information, namely the prosthetic information, to have a precise planning and precise outcome. Same case as before. I think you will agree with this amount of scatter, with a lack of prosthetic information. It's very difficult for us to plan prosthetically correct. So it's just a rough estimation where it could be true and where the optimal implant position could be, but it doesn't have anything to do with precise planning. So what we did in the first hand was to take, of course, the impression of the current situation, scan that with a three-dimensional scanner, and superimpose that with the X-ray, with the cone beam scan. But also here, we have a bit of added accuracy because we can hide all the scatter, all the artifacts. But as a matter of fact, a precise implant planning for the prosthetics is also just not. Just another angle of that image. So you see we have a bit of prosthetic information, but actually not enough to have a precise outcome. So what's the easiest way? And that is something which is very often not done, but it could be done that easy, because most patients that have like huge gaps and huge free ends, they have kind of a prosthetic restoration. they have prosthesis, for example, or partial prosthesis, partial denture. And the easiest thing nowadays is just to do a superimpression of the patient with the remaining teeth and the partial denture. And then we do a plaster model of that. And with the remaining teeth, which we see both in the cone beam scan and the plaster model, it's very, very easy to superimpose those two data sets. And the result is very impressive because suddenly we can see both. We can see the bone and the prosthetic information. And that is also very, very affordable because you just need one impression, you need one stone model. You can scan it three-dimensionally. And nowadays you can also do just an additional intraoral scan, which would not be any additional cost. And then you have a data set of the current prosthetic situation, and you can integrate that into the digital workflow, which will help you immensely to find the right implant positions here. Also another angle, so then you're able to adjust the implants to the bone, to the prosthetics. You see which implant you need in what precise position. And also to explain it later to the patient is much easier if you have the prosthetic situation integrated and can explain the patient on that specific position, on that specific spot with that image, what the situation is and what you're planning with him and for him. And not only that, you can, in the X-rays, in the cone beam scan itself, you have a superimposition of the outline contour of the plaster model. So you can see where the implant will be, you can see what the axis will be like for the later prosthetic work. And then it's so easy to adjust the implant to the optimal position. Okay, second example. What else can we do in an easy way to use digital techniques also with an analog way to help us doing a precise case planning? In this case, the patient didn't have any partial denture. So this was the current situation. Of course, you do a cone beam scan, you do a plaster model, and it looked quite okay for the case planning because it's just a smaller free end. But also in this case, just okay wasn't precise enough for us because we wanted to go the extra meter. So what we did is we gave the stone model to the technician, say, hey, I just need some wax teeth, so a very, very quick wax up. I don't need any radiopaque material, I don't need any markers, I just need on that stone model, which is, by the way, also in this case, not the best quality. But in this case, just for the prosthetic planning, that doesn't matter much. But I just need some teeth at the position where they have to be. So the dental technician just took very, very easy wax teeth, added them to the model, to the stone model. And the result was that we could also superimpose that to the current planning and then optimize the implant position to the optimal positions in the jaw. And as I said, not only regarding the bone quality and bone shape and bone volume, but also for the prosthetic outcome. So what does retrospective backward planning mean? You can add additional plaster models even after the cone beam scan. And in most cases, an overimpression about the current interns prosthetics, so partial denture, is sufficient. And what is important, you can also do wax up without a special material or radiopaque markers. And third point about that, of course, if you have an intraoral scan and can use the intraoral scan to do a virtual setup, that's even easier. Then you do the virtual setup directly on screen, export that data set, and import that back again into your case planning software. And then you have your prosthetic planning integrated in your case planning. And that is so easy, it's so fast, that I can't understand why it's at the moment only done in maybe 10% of all cases. Prosthetic implant planning is prosthetic planning, so we should start from prosthetics, and it's so easy. So if we have the surgical guide, if we have the prosthetic planning, if we know where the implants go, of course we need a certain surgical tray. Just want to give you a rough overview about our BEGO guided surgical tray. We actually have two different trays for the guided surgery. We have one tray for the straight implants, so S-line, SC, SCX line, and one tray for the conical shaped implants, the RS, RSX line. And what we wanted to have is we wanted to have a maximum flexible system with a reduced amount of drills. So what we did is we excluded the diameter 5.5 from the surgical kit, because if you have enough bone to use a 5.5 millimeter implant, usually it's okay to just drill up to 4.5 and do the last step freehand. And though this way we could reduce the number of components significantly, and what we also wanted to achieve is the implant insertion directly through the guide. So quick overview. One of the major components that we have is the spoons or drill keys. They have a special technology integrated, which we call self-locking spoons, because it's the only spoons on the market which can be locked in position within the surgical guide. So the spoons come with a certain bayonet locking mechanism. You put in the spoon, rotate it clockwise, and then it's locked in the surgical guide. It cannot fall out, and thus you don't need a third hand for holding the guide and the spoon in place, and have one hand free for drilling. You would start with a tissue punch. You can use it directly through the guide. So you can do a transgingival treatment using surgical guides. But what I always say is it's not mandatory. Guided surgery doesn't mean that you do everything through a pinhole, that you do everything transgingivally. It offers the possibilities to do so, but you are to decide if it actually makes sense in that specific case and with that specific patient to do it transgingivally. Most cases that I know, like the majority of cases using surgical guides, are still to be done with a flap, because if you do tissue punching, of course, you lose a bit of tissue, and especially in the aesthetic zone, most likely you don't want that. So it is your choice. Guided surgery offers you the option, but it's on you, up to you to decide whether or not you need and want it in that case. Okay, then we start drilling. The drilling is done with a tool called center drill. It's directly through the master sleeve. So it gives you a very, very precise initial drilling because it's guided without a spoon, with a very, very huge diameter directly through the master sleeve for the first up to approximately 5 millimeters. And then afterwards, you take the normal depth drills, which you then drill up to the stop, because every guide is manufactured in a way that the sleeve is on the right position, so you can use each separate drill up to the physical stop. There's a certain protocol that comes with the guide that tells you which drill to use, so which drill length to use and which position. Afterwards, after the drilling, of course, you can use the countersink and the screw tapper. That can be also used through the guide. We have a special component called the connector, which, as the name says, connects the handpiece with the countersink or the screw tapper. Or, and that's also the advantage, with the implant itself. So you first take the connector, adjust it to the right depth, and then you can use the countersink if needed, the screw tapper if needed, and also then you can insert the implant through the guide itself. So then you have a full guided treatment. But also here, if you want to insert the implant through the guide or not, that's your decision. I know in a huge number of cases, or in a certain number of cases, surgeons prefer to insert the implant not through the guide, because they want to see and they need to see what's going on in the bone. Especially if you have compromised cases where you have a lack of bone and need to augment or do the bone spreading in advance. Also there, it's not necessary to insert the implant through the guide. Just because it's possible doesn't mean that it makes sense for you in every case. It's your decision, and we can just offer you the possibilities. So that's it for now. That's like a rough overview about the possibilities that you have with digital dentistry. I hope I was able to show you some tricks, some tweaks, how you can use guided surgery, precise and easy, and above all, affordable and fast, in a way to have the most, well, the best quality outcome here. To add prosthetic planning to a surgical planning, to an implant planning, and that the cone beam scan is an important part of the information for sure, but it's not the only part of information that you have. Digital dentistry enables you to combine different parts of information, different layers of information, and it's up to you to pick those layers of information that are important for you. And it's nowadays just so easy to combine them all. So I'm open for questions now. You can use like the chat window in the GoToWebinar window. I'm happy to answer your questions. If not, of course, I'm really thankful for your attention. And once more, I hope you all stay healthy, you all stay safe, and we all will see each other very, very soon again on either a BEGO event, on a conference, or somewhere else. So thanks very much for now. Take care, and waiting for your questions now. Thanks very much. So let's see if we get questions. Nothing so far. In the meantime, it is for me very, very interesting to see this development of guided surgery. I'm working now almost 15 years in the guided surgery industry. And when I started, it was very, very expensive to use guided surgery. When I started in 2006, you could calculate very easy, approximately €1,000 extra for a surgical guide. You needed the CT scan, which was around 200, 250 euro. You needed the scanning prosthesis with a certain radiopaque material, which was often another 200, 250 euro. And then the printing of the surgical guide costed also around 500 euro. And then you also needed the software. And when I was selling the software, even the small version was 3,500 euro, and the pro version, the big version, was way above 7,000 euro, even without VAT. So it was very expensive, and nowadays it's much, much cheaper, much easier. So questions, there they are. Where is this? Yeah, the question is if there is an indicator for the hex orientation on the insertion tool, and the answer is yes, there is. The connector has a flat edge or a flat side, which directly reflects also the flat side of the hex. So when inserting the guide, the implant through the guide, you can also see the hex rotation. That's, by the way, the case for all BEGO insertion tools. Like whenever a hex comes to a hex, they are always matching. So in the whole process of like an insertion tool and the hex on the insertion tool, it's always the same rotation that you can always see where you are. Can you please repeat the name of the Facebook dental group that you have mentioned in the beginning? Yes, of course. The Facebook group that was mentioned is called Dental Bloopers. So it's spelled B-L-O-O-P-E-R-S. That's like the group for like dental fails or like cases, interesting cases from like, yeah, actually surgeons all over the world. It is really, really entertaining. So next question, how do you place the implant on the insertion tool? Is there a transfer key or something? Well, the insertion tool is the same insertion tool from the connection like every BEGO insertion tool, and that has the connection to the implant insert mount. So every BEGO implant comes pre-mounted with a special insertion post. I'll quickly go to the presentation because there we can see it. I can hope you still have the view. What you see here in silver, of course, is the implant. In red is the insertion post. It's not the precise image here in this graphic, but the insertion tool itself is just put onto the implant. So you take the insertion tool, go with the insertion tool into the packaging and directly can pick up the implant. So you don't need any transfer key or any additional tool. You just open the implant packaging, take the insertion tool or the connector and just go into the packaging, pick up the implant, and you can directly insert it. So, is it easy to drill in posterior regions using spoon or other accessories? That's a very good question, because of course mouth opening is always an issue when using a surgical guide. But for that purpose, we have 3 different drill lengths. So the lengths are 18 millimeters, 23.5 and 29. Of course, you will never be able to use a 29 millimeter drill in the posterior region. But I don't know when you had the last case where you were using like a 13 or 15 millimeter long implant in the posterior region. Usually the implants in that region are much shorter. So we are able to adjust like the sleeve position, not depending on the implant length. So when we have a short implant, of course, we can use a short drill if possible. We can also use a longer drill if we have the situation for it. But also what we do is, if we know that we have a limited mouth opening, we are also able to directly visualize the sleeve within the planning software to see which drill we would need within the surgery. And in some cases, if you have, let's say, the choice of placing a 10 millimeter implant or 11.5 millimeter implant, and you see within the case planning that the 11.5 would be needing the medium-sized drill and the 10 millimeter implant the shortest drill, then you can change your planning to the 10mm implant so that you can use the shortest drill possible if you know that you would get problems with the mouth opening. So saying that, it is possible, but of course it's not a secret that without a guide it's sometimes easier to reach certain areas, but there are ways to cope with that. Another trick is, because the master sleeves are quite wide, you can put the spoon on the drill before you put the drill and the spoon into the mouth. That's how you can like put the drill in an angle which enables you to like get the handpiece around the opposite jaw, and then straighten it up, put the spoon down into the master sleeve, lock the spoon, and then the drill automatically is in the right position. I hope that answers the question. So how much time do you need from first planning to delivery of the guide? Okay, that is a question regarding our planning service that we at the moment have for Germany and some European countries such as Spain, Greece, Croatia, Slovenia, and more countries are in the planning at the moment. You can say that as soon as we have all data, usually the planning is done same day or next day, and if you approve that planning, then the guide will be shipped 2 days later. So the whole process is very easy possible within 1 week. We have a special express service where we speed up things, which comes at some like extra cost, but there we can also be faster than that. So just in theory, if everything is done right and we have the data, technically we could ship the guide next day. But then we would like need to put aside all other cases, just work for that case, and that comes of course as a price. But usually it's within 1 week. But what we see is that like most surgeries are planned like 2-3 weeks in advance. That's like the average duration of like between the ordering of a case and when the surgery will be. And for us, it's very, very easy to meet that. So another good question, how do you compare the accuracy of intraoral scan and plaster scan? Well, the thing is, when we are superimposing either a plaster scan or intraoral scan with the cone beam scan, of course, we can compare the outline of the scan of the plaster model or intraoral scan with the cone beam scan. And it's very, very quick that we see deviations in the models. So if we have a deviation either in the cone beam scan or in the model, we see that those contours don't match. And that would be the point when we are either requesting a new scan or a new model. And if we compare intraoral scan with the plaster model scan, the plaster model scan still is way more precise. Also, if we scan the soft tissue, which is very, very useful, especially for maxillar cases, then we see a big advantage towards the plaster model scans. Of course, intraoral scans are sufficient, but what I always recommend is if you do a surgical guide based on an intraoral scan, as soon as you have the guide, ask the patient to come into your office just to try it in, that you know that the guide will fit during the surgery, because there is a higher margin of error and there is a higher chance that you have an error. And then it would be a shame if you have like 2-3 hours surgery time planned and then the guide doesn't fit because there was something wrong with the intraoral scan. Also with the stone model, it's never a bad idea to ask the patient for a very, very short appointment just to try in the guide so that you're sure that it will fit, and then you're safe for the surgery. Next, what kind of image distortion do you expect in CBCT volume? Well, first of all, we have usually a voxel size of 0.3 to 0.4 millimeters, so 300 to 400 micron. So the surgical outcome, first of all, cannot be more precise than that. And that is like if the image is done without any errors. As soon as we have a small movement in there, of course, the inaccuracy in that case will go up. So mathematically, the result cannot be more precise than twice the slice thickness, because if you put a guide on and if you do the matching, like the real outline of the tooth can be either in the upper slice or in the lower slice. So if the slice is 0.3 millimeter thick, you have a theoretical precision of 0.6 millimeter. There is, when it comes to distortion, there is some theories about that there is also like a small amount of image distortion in cone beam scans, but also depending on like the devices themselves, different manufacturers, different types have different kind of distortions. I'm fair that I haven't seen that much of distortion in cone beam scan that was not due to an obvious movement, and we can kind of exclude that distortion with a plaster model scan for added accuracy. So do we have time for one more question? One or two? Yes, very quickly. What kind of, how do you assure the cooling of the drill hole? Also very good question. If you drill intermittently, you will always have enough coolant on the drill, because what is a very, very common misconception is that if you drill with an external cooling, that you get cooling into the drill hole. Because if you have the drill in rotation, every drill is designed to take the bone out of the cavity, take bone out of the drill hole. That's the same that happens to water. And also if the drill is spinning, due to the rotational forces, the water will not stay on the drill itself. So you're always cooling indirect. And that doesn't change much if you're drilling through a sleeve or directly into the bone. So cooling is a bit reduced, yes, because you have the sleeve and the additional distance. But if you drill intermittently, you don't have really an issue there. So what kind of tolerances that can occur to several steps in digital processing? Well, that's what I answered also with the cone beam scan, with the accuracy of the plaster model. Da haben wir noch zwei. Can you sterilize the guide? Well, that depends on the material that you're using. If you use a 3D printer and you have an autoclaval material, then you can, of course. Our own guides at the moment are not able to be sterilized, but we are working on a project that they can be. I hope that we would have this project ready this year, but now due to the crisis, it can be that it is a bit prolonged, but I don't have an exact date about that. Yeah, and that's a very, very good last question. Tell us something about your goal achievement when you reached the peak of mountain, as you had shown in your last slide. Well, the last slide, that was Mount Kilimanjaro. That was now 3 years ago. That was standing on the top of Africa, actually. And well, that was not the aim or the finish of of a big project, but actually the start of a project of like new challenges, new travels. Last year I went in the Everest region, saw Everest from up close, went again above 5,000 meters. And yeah, as soon as traveling is possible again, I think there are some new challenges to be worked on. And yeah, I hope to be able to well, keep you posted on that also in the future. And as I said, thanks again for your attention, and hope to see you soon on a BEGO event or on the next webinar. I hope you enjoyed watching this. Stay safe, stay healthy, and hope to see you soon. Thanks very much. Bye-bye.